I'm going to look at a right triangle and the side ratios which define the trigonometric functions. The very first function I have up here is sine, and it is derived from Latin. The second one is cosine, which is the complementary sign, because there's a relationship here with complementary angles. And then lastly, we have the tangent. I like to explain this. When we look at the angle of interest, the input value, the independent variable, I like to think of standing as if I were physically in the corner of this triangle. And I look out at the triangle, and across from me, like a wall opposite of me, will be the opposite side. The two walls that I could reach out and touch would be walls that are adjacent to me. One of those walls that's adjacent to me is the hypotenuse. The hypotenuse in a right triangle is always the hypotenuse. We can always label that one right away. So this is the way that we can properly label our triangle. Based on the angle of interest, in this case theta, that's the one that was put into the functions here, we have this diagram mapped. Sine is going to be the opposite over the hypotenuse. Cosine is going to be the adjacent over the hypotenuse. And sine is going to be the opposite over the adjacent. Something interesting about the tangent function here is it can be defined in terms of sine and cosine. We can say that tangent of theta is equal to sine of theta divided by cosine of theta. And will this give us this? Let's explore that. If I take the numerator here and replace it with this ratio, I will have this. And in the denominator, I'm replacing it with this. And I have this. If I look at these two inner terms, that will become the denominator. If I think about simplifying this fraction, and the outer terms are going to be my numerator. We see I have a hypotenuse in the numerator and denominator. These are being multiplied, so that means that's reducible. And when I reduce those out, I end up with the opposite over adjacent, which is what I determined up here was going to be the side ratios that were going to be assigned with the tangent function. So we can see that we can either use this expression, this ratio, or we can use this expression, this ratio here. These will give us, these are the same values. Hopefully this helps with understanding how to label our triangle, what ratios should be used with each of the basic trigonometric functions, and how this ratio of sine to cosine relates to tangent and is still the same valuation as opposite over adjacent. Cheerful calculations.